looking at pages 50 to 58 and the mistakes people made on number 1, right? So you can share this with your parents. The question wasn't what fraction of the whole you were trying to figure out, but if 3 people are sharing this 5-segment gummy worm, here are the 5 segments. They're this big. Each person would get 1 whole segment, like this, the green, 1 whole segment plus a third of the leftover 2 segments. So each person gets 1 2/3 of a segment. So then the red person gets this whole, and this third, and that third. Better?
Yeah.
Okay. Okay, and then the person, this one gets that whole plus this little third and that little third. Okay, that kind of thinking is important today. So let's keep going then. That brings us to problem 2. Show 2 ways 5 people can share a 3-segment chewy fruit worm. So for 2, let me just copy a few of these guys here. I'll make a 3-segment chewy fruit worm here. So for number 2, we're going to start with 3 segments. And 5 people are going to share it. So, Allie, so we have to share between 5 people. Good. Okay, so nicely done. So we know that the least common multiple of 5 and 3 is 15. So we could break this into 15 parts. So I have to divide each segment into 5 parts. So that's a good first step. And now I'm going to share it between 5 people, right? So each person, when I take that 15 and break it into groups for 5 people, I would have 3 in each group.
So everybody gets 3?
So everybody gets 3 what?
15s.
No, because the segment is like the green
Yes.
chunk. Yes. So each person gets 3/5 of a segment. You get that? Okay. So not 3/15 of the whole worm. Better? I want to show you something, you guys. You can do this with the ratio table, what you do in your homework tonight. Oh, it's in the phone. Okay. So if I just shrink my writing, wouldn't it be great if we could do that? If I had a ratio table that told me the number of segments and the number of people in a ratio table, then in this original problem, remember we had 5 people and only 3 segments. Okay? And so if I want to figure out what part of a segment each person gets, I'm looking for something called the unit rate. I want to figure out what part of one segment does each person get. So I would have to get a 1 here by dividing by 3. Does that make sense? And so I have to divide 5 by 3. But you know, Yeah, no, so, do I wanna do it the other way around?
Yeah. But I'm multiplied by 3. Yeah. Divided by 3.
Well, I wanted to switch this around, actually. I wanted to have, sorry about that. I wanted to have, segments here and people here. The other one wasn't wrong, but it's not what I meant to do. I mean, it wasn't helpful. It would have been confusing. So we know that there's 3 segments per 5 people, right? And we want to figure out how much each one person gets. That's what I was trying to say. I said it wrong the first time. So if I divide this by 5, now I have a 1 here, right?
Yes.
And I can figure out what fraction of a segment each one person gets. And so I'm going to take my 3 and divide it by 5. And what I was wanting to show you is that you guys maybe learned last year that fraction bars mean divide. So 3 divided by 5 is just 3/5. So no, you just write 3/5. That's 3 divided into 5 equal parts. Because look at, we did it over here. We took the 3 segments and divided it into 5 equal parts. Here are the 5 equal parts, right? And each part is 3/5 of the whole. So I think the picture makes this sense, but this kind of understanding of dividing by 5 with a fraction bar is going to be helpful for today. Okay? Echo.
I also get where you times them by 3 and then divide by 3.
Yes. So you could also absolutely, you could do different things in a ratio table, right? We could have
Multiplied by 5.
multiplied by
3.
You could do all kinds of multiplies and divides in here, but
That equals 3 because 3, that's 9.
so what she's saying is you could do like 9/15, right?
And then divide it by 3 to get 11.
Yes, you could do all kinds of things in a ratio table that are true, because 9/15 is in the same ratio as 3/5. But in this particular problem, even though you can do that in a ratio table, it's not something that is going to be useful in this problem, but the skill's useful in other problems. Okay? So you're right. I'm going to undo that for this problem, just because it's not something that's going to be useful in this problem, but we are going to use that skill sometime. Let's go to the third one. So on the third one, it's a little bit different. It's a 4-segment chewy fruit, right? And you're supposed to give 2 numbers of people that could be in Sharon's group. Okay? And the deal is, you can't put any more divisions in it than the divisions that are shown. Okay? So how many people, let's pick some people, 4 and 6. You want to do 4 people? That's a pretty easy one, so we should start with an easy one. If there's 4 people, they're sharing 4 segments, right?
Yes.
So that's not such an interesting one, but it's important that you know, understand the basics, right? So that just means every one person would get 1 segment. So it's not a problem that it's not interesting. We want to make sure that you would see this is 1 segment. So like maybe this is Jen and Caden and Peter and Zoe, right? So if there's 4 people, it's really easy to see that, okay? So if I continued, though, and did it a little different, and another little table setup, she said, what about 6 people? 6 people is a little more interesting. So if I have people and segments, that's an S, people in segments, if there's 6 people, they're still sharing the 4 segments. You get that? They still have to share the 4 segments. Okay? So if we look at that, we want to think about the picture again. So let me just snap a picture of the one we have so I can erase. I'll shrink it. This was the first one. So kind of like your homework would have a picture. And we'll just shrink that up and bring it back to where it belongs for this one. And then I'll erase our bar and do a new one. So for 6 people, we're going to start again. Same problem, but different people. Okay, so this one goes with the ratio table right there. But if I want to do 6 people, there's 12 little pieces, right? So, you know, there's, just if you were kind of doing it yourself, you could just think of it this way, right? And so each person gets what fraction of a segment? 2/3. 2/3. Do you see that?
Yeah.
So look at how this works. If I divide by 2, right? I would get a 3 and a 2. But we want to get each person, we want that unit rate, we want to know what one person gets. So we have to divide by 3. And we're going to divide 2 by 3. And the fraction bar means divide. So this means for each person, there is 2/3 of a segment. Does that make sense? Okay, Connor.
Would 12 work?
12 people?
Yes.
Yeah, so 12 is easy, right? For each person there is 1/3 of a segment. Okay?
Isn't it pretty much multiples of 12?
So there's factors, right? Any factor of 12 would be the you could do without making extra chops, right? Do you get that?
Yeah.
Okay, so I think we could put that to rest then. Anything else on the homework? So should I go to 25?
Yeah.
Oh, what was the answer?
Yeah.
I don't remember. Let's see, 25. Ursula, Ubaldo's, and Dora's strategies work.
So all of them work? Except Ulysses.
Not Ulysses. Okay. What? I could do one of those.
No, like.
Oh, you should have put all of them. You misunderstood the question. I would just go back and look at it and make sure you understand.
Wait, so you should have put all of them?
You should have. No. In other words, if you didn't, I think you missed it. When they said which of these strategies, they mean give all the. They should have done a better job of asking the question. Give all the strategies that work. Would be a better way to ask the question, right? Yeah, I agree.
Yeah.
I don't think they did a great job asking the question. What I'm saying to you is, can you just check in your time, like make sure you understand why all work? Okay? I'm going to post this at one more